Our lesson on 3.7, it's the first full return to Algebra 1 topics. Today's focus is graphing and writing the equations of lines. If you are so interested in doing your Math Excel for this section, you're also more than welcome to after completing our lesson. Here's our first topic. The first topic we return to is the concept of slope, because in order to write the equation of a line, we need to know a few facts about the line, such as a slope. And to find the slope, we actually need to know a couple points that exist on a line. So what is slope? Slope is the variable m that we often refer to. And officially speaking, slope is the ratio of the vertical change, the rise over the run. And we use this equation here to identify the rise over the run. Notice it is the change in our y values over the change in our x values. And when I say change, that's why I'm taking the difference. We're going to subtract the y values and we're going to subtract the x values. And we divide the y value difference by the x value difference. So let's use our new knowledge in our very first example. Here is our first graph, and we need to identify two slopes. One of those slopes is the slope of line B. So I notice on line B I have two coordinates. I have a coordinate at -1, 2. And I also have a coordinate of B located at 4, -2. So to find the slope is represented by the variable m, we need to find the change in y over the change in x. That little triangle, by the way, is just our symbol for delta, which just means change. All right, I'm going to stick to using these values first. So I'm going to use the y value of 2 first in my little expression here. So if I'm using 2 first on the top for my y, I got to use -1 first for my x in the denominator. And we're going to subtract the values in this second coordinate that I see. So my second y value coordinate is -2. My second x value coordinate is 4. So now I just need to simplify the expression. 2 minus -2 becomes 2 plus 2, which is 4. -1 minus 4 becomes -5, so my slope for line B is a slope of -4/5. All right, let's take a look at our next one. The next slope we're looking for is the slope of line D. Line D contains the coordinate 4, 0 and a coordinate 4, -2. Once again, to find the slope, we're going to need to do the change in y divided by the change in x. So delta y over delta x. Let's use this coordinate 4, 0 first. So we have a y value of 0, and I'm going to put my x value of 4 in the denominator. And we are going to subtract this second coordinate's values. So once again, I'm going to put -2 up on the top for my y value, and I'm going to put 4 on the bottom for my other x value. 0 minus -2 becomes +2. 4 minus 4 is 0. Well, I'm hoping that you remember that you are not allowed to divide by 0. Therefore, we know that this slope is undefined. Please make an observation. What kind of line is line D? Line D is following a vertical path. D is a vertical line. Please notice in our question for a slope of B, B had a negative slope, and notice that it's appearing to go down as it goes from the left to the right. Here is your first got it question. You are finding the slopes of line A and line C in our same picture, which is the same picture that is in your notes. Please check your answers. Hopefully you got the slope of 4/3 for line A and the slope of 0 for line C. After completing this first example, I'm hoping that you noticed that you had 4 different types of slopes that were possible. We had a possibility of having a positive slope, such as the one in line A, which moved upwards as you went from the left to the right. When we did line B, we noticed that we moved downwards from the left to the right, which was a negative slope. You had a 0 slope for line C, which occurred when I had a horizontal line. And I had an undefined slope when I had a vertical line going up, down. All right, let's take this a little bit further. 2 types of equations of lines that you have learned before are the slope-intercept form and the point-slope form. Slope-intercept form is most common, it's most widely used. That is our y equals mx plus b format, where once again, m is the slope, and b is going to be your y-intercept. Y-intercept is where you intersect the y-axis, aka this is where you have an x value that is 0. The point-slope form of the equation is also helpful. In this format here, you need to have one point, and you need to have the slope. Slope is still going in for m, and we're going to use a coordinate which we call x1, y1. Notice in this equation, we have y minus the y value coordinate, and we have x minus the x value coordinate. Something I'd like to point out is that we can only write equations of these lines in this format so long as the lines we're dealing with are non-vertical lines. All right, let's take a look at our very first two examples here. We need to graph these lines given certain criteria. In question A, it says y equals 2/3 x plus 1. In this format, I know that 2/3 is a positive slope. A positive slope with a rise of 2 and a run of 3. So I'm just going to make a little note to myself, I should be going upwards. And my positive 1 is going to be my y-intercept. So I'm going to plot my y-intercept at positive 1. Alright, so now from this coordinate, I need to go up 2, so 1, 2, and over 3, getting myself this new coordinate. And I'm going to go up 2 again and over 3 again. Now notice that when I plotted these, it only gave me to the right of my coordinate. To go to the back side of my coordinate, I need to reverse what I did. So I'm going to go down 2 from the green dot, and to the left 3 units. And so this will continue my path. Let's take a look at equation B. In equation B, I was given a point-slope form, where I have a slope that is -2, which means I'm going to go down from left to right. -2 actually means that my slope is -2 over 1. So down 2 over 1 unit. Now we have to be careful of point-slope form. We've been given a coordinate, but notice in our format we're supposed to be subtracting. So anytime I see addition, I actually know the coordinate that is contained is the opposite sign. So inside the x quantity I see a positive 3, so the coordinate on my line is actually -3 for the x value. When I see y minus 3, I know that the y coordinate is actually going to be positive 3, and this is a coordinate that I should plot on my graph. So I'm going to go over -3 and up 3, and here is my coordinate that's been provided. From this coordinate, I'm going to do a slope of -2. So I'm going to go down 2 units and to the right 1 unit to plot this point. Down 2, right 1. Down 2, right 1, and here creates my line. Again, to create the back half, I'm just going to do the opposite. So I'm going to go up 2 and to the left 1 unit, creating the back side of this graph. All right, it is now officially your turn to graph these two lines. Let's check your answer. These are the two graphs that you should have created. Please make sure your slope is positive and your slope is negative when appropriate. All right, let's continue on. Let's write equations of lines, given certain information. What is the equation of a line given the slope is 3 and the y-intercept is -5? When given the slope and the y-intercept, it's most efficient if I use the format y equals mx plus b. Alright, so we just got to plug in. Y equals, well, my m value is 3, because that's my slope. So I'm still going to have an x. Now I have a y-intercept of -5, so I'm going to subtract 5. And here is my equation of a line given this information. In next question B, I've been given a point and a slope. When I'm given a point and a slope, it's most efficient if I use point-slope form. So y minus y1 equals the slope times the quantity of x minus x1. Alright, so let's get started. We know we're going to have y, and then I need to figure out minus y1. Well, my y1 coordinate is 5. So I'm going to subtract 5. This is going to be equal to, all right, well my slope is 2. And it's going to bother me if I don't fix that. That should be green as well because I'm trying to remain consistent here. Multiply by the quantity of x, and then I'm going to look at my x coordinate of my point that's been provided. My point that's been provided has an x coordinate of -1. So when I subtract -1, it becomes +1 inside the quantity in parentheses. As a side note, this is just a brief review of Algebra 1. I do expect you to have the ability to go from point-slope form to slope-intercept form, aka isolate your variable y and simplify. Here's your turn. Write 2 equations of a line. All right, these are your 2 answers. I hope that you check over your work and look for any mistakes. All right, what is the equation for this line at the right? All right, notice that I've been given 2 coordinates. When writing the equation of a line, it's most helpful to first identify the slope. The slope here, once again, is going to be the change in y divided by the change in x. All right, y values. I'm going to use the coordinate of 3, 5 as my first coordinate. So I'm going to place 5 in the top because it's my y value, and 3 in the bottom because it's my x value. And I'm going to subtract the second coordinate. The second coordinate being -2, -1. So -1 is going to go in the top, and -2 I'm going to place in the bottom. And all I need to do now is simplify my expression. 5 minus -1 gets me +6. 3 minus -2 gets me +5. So my slope is 6/5. All right, well I could very easily find the y-intercept if I'd like to, or I could write this in point-slope form because I also have a choice of 2 coordinates. So here is point-slope form once again. I'm just going to pick whichever coordinate I want. I'm a huge fan of 3, 5, so I'm going to choose 3, 5. So we have y. My y coordinate is 5, so I'm going to subtract 5 is equal to, well, we know that our slope is 6/5. Multiply by the quantity of x. All right, once again, the x coordinate I'm using is 3, so we're going to minus 3, and I just have to close my parentheses. And here's the equation of the line at the right. Once again, it is an expectation that you have the ability to turn this into slope-intercept form. Here's your turn. All right, so let's check your answer. If you did not get the answer correct when converting it into slope-intercept form, please check over your work. Please remember how to isolate your variable. Last problem. What are the equations for the horizontal and vertical lines through the coordinate 2, 4? Well, let's first talk about the horizontal line. Notice in the horizontal line, the points that are contained inside this horizontal line, all of these points have one thing in common. They all have a y value of 4. Therefore, the horizontal equation is y equals 4. The vertical equation. Notice when I draw a vertical line through that coordinate, all points on this line have one thing in common. The one thing in common that they have is an x value of 2, getting me a vertical equation of x equals 2. All right, here's your turn. You should not need a graph in order to complete this question. All right, here you go. All right, so like I said at the beginning of the lesson, if you are so enthused, if you are so interested, you are more than welcome to now start working on your Math Excel. If this is not one of the strong suits that you remember having from Algebra 1, please make a little note to make sure you come and see me so that we can get you stronger on your Algebra 1 skills. Have a great day.